I'm Nick Sviatecki. I'm a leader in the product management group. I jokingly say that what I do is access points, and access points. My team does a little more. We look at a lot of the 802.11, a lot of the RF near features that we're doing. First-time presenter here at MFD, a long-time viewer. Shout out to those that are sitting in Europe during their dinner watching the sessions. Used to do that. With me, I have Anand, who'll help me with the demos in just a second. By the way, that's me. If you want to tweet at me, some of you already do, go for it. Anyways, what we'll be covering today. We're going to be talking about 6 gigahertz Wi-Fi as of today. We're going to demo what AFC looks like on Cisco wireless. So that is both Catalyst and Meraki, and I will be doing that. And then we're going to be talking a little bit about the future of wireless. That's a dangerous topic in a room like this. But we think it's, apt to talk about that at this point in time. Of course, if there's any questions, shout out. I know you guys probably will. Now, I want to actually start with where I'm going to end. I hope you all agree that Wi-Fi in 6 gigahertz was the paradigm shift, not so much the, let's say, different Wi-Fi Alliance generations 6E or 7. We got access to this brand new spectrum, truly revolutionary, and that's what we're going to be talking about today. By the way, if anybody disagrees, let's talk afterwards. I would love to hear that. Now, before we start talking about speeds and feeds, this is what I like to call the Wi-Fi trifecta of readiness. Other people might call it something differently, but this is how I like to view and how we like to view how ready are we for a new generation of wireless. Right? We have the regulatory, the specs, the certifications. We have the clients, the hardware and the software part of that, drivers, OSs, and of course there's the infrastructure, the hardware, the software, our software. And all of this kind of has to come together at the right point in time, at the right level of stability for Wi-Fi to be ready, first for consumers and then for enterprises. Now, typically you would see Cisco, or maybe think of Cisco as an infrastructure player. But for 6 gigahertz, we've been very active kind of in the red circle here, super active in the regulatory, in the specs, also driving some of the changes that have been needed to the specs, and we're going to talk about that a little later. So keep this model in mind. Sam, I'll look at you later. I'll ask, do you remember this slide? And I'll ask you a question, okay?
Fair enough.
Great. So the sum of this is what I'm using and what we're using to kind of look at where are we today for 6 gigahertz wireless. Now, I've made a bold claim, and I'm going to walk over here, and I said, we're right about here. We're past the chasm of, are we ready for 6E? Yes. Not even a question anymore. 6 gigahertz wireless. We have clients from Apple, from Intel, the Lenovo's, the Dells, the HPs. They all have 6E. Running Windows 11, it supports 6E, right? All the specs are there. Been out for quite some time. So what I'm saying is, for 6E, it's no longer a question, are we ready? We're selling tons of 6E APs. They're getting deployed out there. Minza talked a little about WPA3. I'll touch upon that a little bit as well. We can do a little contest about who loves transition mode, who hates transition mode. But this is where I would argue we are today for 6E. First, why are we there? Well, we're happy to report that all of the clients prefer 6 gigahertz. So our test teams do an amazing job of testing every single client. And, Minza pointed this out. Clients may or may not be the worst behaving client or part of a wireless network. We do extensive testing on every firmware version with, every device out there. And truth be told, when we started this journey of 6E, this was not the case. So a massive thank you, of course, to all the client vendors, software guys, driver guys, optimizing the roaming algorithms to make sure we take care of this new band. But we're there. If you looked at some of the old VT slides or our presentations, this was not the case some time ago. So clients, we're good. Oh, sorry you didn't get that, but we'll get to that. Now, what about the infrastructure? Well, from a Cisco perspective, we've been ready for quite a while. We have the broadest, most comprehensive portfolio of 6 gigahertz access points out there today. There are a few new ones, and yes, we'll talk about those. We started with the 9136s and the MR57s, flagship APs, still the flagship access points. And about a year ago or so, we started shipping our CW 9162, 64, 66, our converged hardware, which Fal was talking about, right? Access points that can run in either management mode. And there's a few new faces up here. The 9166D1, we'll talk about that a little later, and we'll talk about the 9163E as well, which is outdoor. Now, some of you might be thinking, wait, there's more 60 APs from Cisco, right? Absolutely. Our IoT BU has, hardened, ruggedized 6 gigahertz access points. I simply couldn't fit them on the slide. But from an infrastructure perspective, mature solution for whatever deployment case you might need. Cool. So let's talk a little bit about the 9163. So the 9163E, and I do have the speeds and feeds slide here, and for those of you in the room, I also brought one along, is the first, let's say, enterprise extending indoor to outdoor 6E access point from Cisco. It is a tri-band 2x2, and I know it's dangerous to put a slide with a lot of speeds and feeds here. I like to think about this as a CM62 or like CW9162 in a ruggedized cover. Now, most people, the first thing they ask me is not the speeds and feeds. Then what do they ask me?
AFC.
AFC. We'll talk about that in just a second. No, you know what I was thinking about? And it's over there is, so Nick, how do I mount that access point?
Yeah.
I'm just going to walk over here and grab this. So this is the Meraki bracket you may know and love from MR86s. And yes, this is the default we're shipping with. But we've actually done one better. This is compatible with the existing Catalyst brackets as well. So all the way from, I think, 1530, what used to be the PMK2 for those of you who speak Cisco PIDs. Yep, works with this, so you can upgrade existing installations. We have new antennas, dipoles. We have a directional patch over here. Not going to show that here. But, self-identifying antennas, all the bells and whistles you've come to know and love from Cisco access points are in this access point. Now, Sam, you mentioned AFC. And of course, for that reason, yes, there is integrated GPS. For those of you who don't know the relevance of those two, hang on for just a second. But we've, of course, built in GPS for AFC. When I say GPS, of course, should be more correct, it's GNSS. We have global band support. We've also added support for an external GPS antenna. So should you want to mount this access point in some awning where there's not, any GNSS coverage, yes, we can support that as well. So that's kind of the hardware side of it, right? Scan radios, 2.5 gig. Again, bells and whistles, of course, migratable between Catalyst and Meraki as well. Just going to pause here for a second. Any immediate questions?
I assume in Europe the 6 gigahertz disabled.
Yes. So the question was, is 6 gigahertz disabled in Europe? Yes, unfortunately. For those of you listening out there, yes, unfortunately. Yeah. Fully available
everywhere else too, right? Because we still can't do external antennas.
Sorry?
We still can't do external antennas yet today, right? So it's disabled everywhere.
Yep.
In addition to Europe.
Yep. So when we talk about the US, and we'll talk about that in a second, we have AFC, and well, Canada is kind of catching up to FCC on that, right? Cool. Sorry. Anyways, so feeds and feeds, right? Now, Sam's point, reminder, if you need any of these three things, APs with external antenna connectors, outdoor use, so weatherized access points, or transfer power of 30 dPm, the FCC wants to know where you are, right? Now, they want to know this to make sure we're not infringing on incumbent 6 gigahertz links. And so you must connect your wireless system to an AFC, and Anand will demo what that looks like, but you must also operate in standard power. Everybody in this room probably has all of this tattooed or over their bed and knows all this. But for those of you out there who might not, we're just going to talk briefly about what does standard power mean for you and your deployments, and then we'll show how to enable it. So this is what the 6 gigahertz spectrum looks like. Coming up in just a second. Of course, in the US, 1200 megahertz of beautiful spectrum we can use indoor. I see Keith smiling. Now, when we go to outdoor or standard power, we're a little more limited on the spectrum, right? We can only use Uni 5, we can use Uni 7, you must use an AFC. Canada is on here, don't worry. and it's going to get access to all of it. And for Europe, well, there is no outdoor solution yet. Europe is discussing what are we going to do for outdoor, but today we'll be focusing mainly on the US and standard power, right? So yes, there's also VLP. I had to add it here. We're not going to talk about that today. But in the US, you must use standard power. So what does standard power mean? Well, slightly higher transmit power, but most importantly, maybe channel widths don't correlate to transmit power, right? So we will see indoor deployments where people are running standard power because they want to make sure that transmit power is not tied, or max transmit power is not tied to the channel bandwidth, right? For low power indoor, that is indeed the case. So what does an AFC look like? How can I use this? How can I take this beautiful AP, mount it, install 4 antennas, and have it transmit an outdoor? So the long and short of it, an AFC is a coordinated database you must call home to and say, hey, I am physically placed right here. Which channels, what channel power can I use? The FCC, an AFC system, which is not run by the FCC, but mandated by the FCC, will tell you, sure, Keith, you can use these channels, these power levels at your given location. We have this fully integrated into 9800 controllers, and I will show that. We have it fully integrated into the Meraki dashboard. So I'm going to kick it over to Anand to run through what that looks like. And then we're going to take any questions on that.
Hello again, and good morning. I know it's been a long journey and a long wait for the general availability of AFC and standard power mode in 6 GHz here in US. But the good news is the wait is almost over, and we are in the final stages of launching the AFC functionality. And it can't be there can't be a better event and a day than today to showcase AFC in action. Very quick intro about me. I am Anand Gurumurthy, and I'm a senior technical leader, technical marketing, focused on the wireless products and solutions. My primary focus is on the access point platforms that I work with my colleague Nicholas, Yogesh, and the team members. And before actually I get on to the AFC demo, I want to share an update, just in case you guys are not aware. AFC is in early field trial in full swing. It's tried by our customers in both the stacks, and we got the experimental licenses for them. And the trial began about a couple of months back, and so we've been getting great feedback, and it's all looking very promising. So what I want to do today is walk you through the the configuration and the monitoring aspects of both the Catalyst 9800 UI as well as the Meraki dashboard. And so the one thing that we have ensured today is to make sure that the configuration is really made simple. Now, if you actually really count, there are only 2 steps where a user has to input something, some parameter or enable a knob. So I'll walk you through what we are doing there. And the configuration is absolutely made simple. And we have hidden many of the the aspects related to the AFC provider, the URL, the credentials, the tokens, and etc. from the user. So the user need not worry about it. So first I'll walk you through the 9800 UI. So what are the prereqs? First, of course, the controller has to be internet reachable to talk to the AFC provider. And the second prerequisite for the access points, the Wi-Fi 6E access points, to operate in the standard power mode, you need the geolocation coordinates. The AFC needs the geolocation coordinates, the latitude, the longitude, and the height of the AP. And what the AFC spec says, so, is that these coordinates is something cannot be manually entered, manually configured, and it has to be obtained in a very automated way, like what Nicholas said, through GPS and GNSS. So, and how do we go about achieving this? So, we have this GPS module, that plugs into the USB port of the access point. It hardly consumes any power. It's just about 0.2 watts or so. You don't need any extra power to operate this, the GPS module. And you can also pop open the cover and attach an external GPS module and another cable in case if the access point happens to be slightly inside the floor, that you don't have a clear sky view. And for of course, the external outdoor access points, you have the inbuilt GPS module, and you also have provision to attach an external GPS module. So not all the access points need this GPS module though. It's enough that few access points in a given floor has this GPS module. The rest of the access point can derive its relative location. Yeah.
Do you have an idea of what that ratio might be in a normal, carpeted environment? 1 to 4, 1 to 10?
We're looking at about 1 to 5, approximate, but purely depends on the deployment, and it's based on the RF neighborship relationships, and if the access points happen to be the same switches, the CDP neighbor list, and so on. But we are coming up with a deployment guidelines, but as of now, it looks like as if like 1:5. That's what you're looking at. Yep. So the very first step is what do? You plug in these GPS modules for the indoor APs, power them up. It's going to acquire the satellite signals and the geolocation coordinates, which you can see in our controller UI. And we have this maps integrated, which gives a precise location of these access points, and also the source, how it obtained its geolocation, whether it's through GNSS, GPNS, or if it's a derived source. This is the very, very first step. And the second step, this is where the actual user is going to input something, the height of the AP. The height of the AP is okay to be manually entered, and it need not be obtained automatically. So you can enter per AP, or you can also do a bulk edit for all the APs in one shot. So once this is done, the next step is what you do is to enable the AFC or the standard power service in the 6 GHz RF profile. It's just a knob here that you enable it. These are the only 2 steps that you need to make the AFC up and running. Yes.
Sorry, just back up a little bit. When you said you input in groups or individually the height, what height is that?
The height above the ground level.
Yeah, so it's not that it's 3 meters up in the room. It's what its elevation is.
Height above the ground level. That's your, yeah. Not the height of just the, yes. And that's all the 2 steps. That's all is needed for you to make the AFC up and running. So give a few minutes. The controller is going to, yes.
Kind of maybe off track a little bit, but I know that there are like wireless bridge vendors that have the GPS built in, and these are relatively inexpensive wireless bridges. Is there any thought to just building it in, or why not just build it in? Again, maybe it's just a terribly stupid question, but
No such thing as stupid questions, right? Now, how we answer them, no, just kidding. This is something we're evaluating, right? For products that are outdoor, yeah, we're going to build them in because you're going to need one for every AP, right? Now, for, let's say, indoor APs, if you're in Europe right now, well, you're not going to need one. So it is something we're evaluating and, considering.
I guess where I'm coming from is it just feels like it would be, and again, out of ignorance, feels like it would be pennies at manufacturing versus something that looks like a lot more expensive.
Yeah, no, I mean, we're considering for future access points. I think the way and the reason we introduced this USB, right, was these access points, first ones launched, but started shipping 2 years ago, then a year ago.
Yeah.
Depending on when AFC was ready. This is a way to make sure we can, enable this for the customers that are going to do it. And then, in the future, absolutely something we're looking at. Now, there are a few things that we can talk about energy efficient glass and how well it works inside. And I think Keith was kind of alluding to how many do you need? We do have an external GPS puck, and some of those deployment guidelines also kind of help, inform decisions like that.
Sure. Thank you.
Does this act as a double whammy for, if you say Europe now, still use the module to help automatically place it?
Yes. Short answer, but yes, absolutely. I think I know where you're going with that question, and big yes.
Because I mean, when you're doing it yourself on Prime or DNAC and getting the angling right and all that, I mean, if you've got the module in there, why not?
Yeah. Let me talk a little bit about that in just a second, but I'll let Anand go through the demo here and then kind of on angling especially. Yeah.
Okay. So now how do we monitor the AFC services? There are different levels.
If I may address this.
Yep.
One other question about the integrated APs or integrated GPS module versus having it external. Even if you have in some of the buildings that are energy efficient and all of that, even if you have in all the APs, signal doesn't penetrate in. So there will always be scenario where you'll need an external module to be connected to it. Now the question is, what's the pivot point when you decide you want to have it integrated versus all external? 6E being the first generation of things, we're starting with external module in the GPS side.
So in towers, how's that going to work where you have low E glass and 30 dB of a signal degradation from the outside to in?
Yeah, so and that's why we have that puck antenna thing that sort of goes out. We have both for indoor as well as for outdoor APs.
So that'll get the GPS through the
You have to,
30
you have to
dB,
find
whatever.
kind of hang it outside the signal so that, and then you have the cable length which is fixed, which will allow it to let in.
You have to get that outside of the building.
Yes, if your building is super energy efficient and the signal doesn't penetrate in, yes.
Okay.
Go ahead.
Okay. So how do you monitor the AFC services at different levels? The very first, monitoring is at the controller level. If you're kind of in a health check, if you're okay communicating with the AFC provider, it's okay here. If something goes wrong, it gives you an error message as to what went wrong. The timestamp of its last successful communication with the AFC provider. And the next step is you can also monitor the individual AP levels. We have this AFC tab where it just gives the current status of the access point, if it's operating in the standard power or low power. And then there is also a request, it just kind of gives the details of the request that it made to the AFC provider. And this is an important tab, like the response tab. This is a response that we got from the AFC that gives the power levels, the max power levels that the APs can operate for the channels and the channel with different channel bits. So, and of course, Uni 6 and Uni 8 is not support for the standard power. So, it's all no response from the AFC service for those. And we also have an aggregated view of all the access points for the AFC services. We have this nice chart that just tells you the number of access points that's actually operating in the SP mode. And it kind of gives the details, like, if, the percentage of APs that you don't know the geolocation, we have all the data here for the admins to act upon it and then see if something has to be fixed here. So and also it gives details support if some of the APs, it doesn't have an active, AFC session. So if you look at here as an example, one of the APs is an inactive. The reason being the height is not configured. If the height is not configured, the controller is not going to initiate a AFC query with the AFC provider. So very similar approach on the Meraki side as well, and just 2 steps. The very first step is to get onto the indoor or outdoor profile, and what you got to do is enable the standard power service. That's the very first step. And the moment you do this, it's going to pop, so gives you a list of all the access points where you need to enter the height. But here is this production setup. It is one of our alpha setup that we are running in Cisco network. So height is already configured, so you don't see that the pop-up menu there. And once you enter the height, the AFC service will be up and running. And here is a tab on the AP page where you can see the AFC status for that AP, and then the standard power that it's operating, where you integrated map view of the precise geolocation, and also the power levels, that it obtained this response from the access point. So, and what we're also trying to do, kind of give a very uniform experience on both the stacks, whether it be Catalyst or the Meraki, the number of knobs that you need to turn on to make these services up and running on a very similar view. Some colors may change here and there, but overall the experience is what, have a uniform experience, what we are trying to work.
A question about the channels view here. Is this what's allowed by AFC, or is this what's the response from AFC, as in the subset of channels that you're allowed to use?
So this is a response from the AFC for the given geolocation, and it gives you the max power level where the AP cannot exceed that power level. So then our RRM kind of gets this value and just kind of use these power levels when it supports it to the access point.
The first question, which I sort of openly acknowledge is unfair. Any idea when?
When we're almost there.
Everybody keeps saying we're almost there. Like, and again, I realize it's not Cisco by any stretch, but
I know the date, but Yogesh wants to.
Okay, maybe I can take this. So from a product point of view, I think all vendors and even client vendors to some extent are almost ready. Their devices are in the lab, it's being certified and all of that. But when FCC decides to issue the cert is when we go to production. Last we heard was it was getting impacted with government shutdown. Now I heard government shutdown has sort of moved away. So it's any day for that matter.
Okay.
Either side of the Christmas.
So realistically, before the end of the calendar year, possibly?
Maybe.
Maybe? Okay. All right. Fair enough.
But it's not very far though.
Oh, not, okay. So yeah, we're okay, months away. And then the other question I had was, I know a lot of my customers are hyper conscientious about where their data goes, data about their network goes, and the like. We're now hooking our controllers and our AP serial numbers and our locations into a system that Cisco then shuttles off to an AFC provider. Can we get some insight into how that happens, what the trust relationship is between that provider and Cisco and the customer? Where is that data going to go? How is it protected? Hey, if I want to excise my data from that system, how do I pull it back out, right? We've just sort of dropped a third party into all of this and everybody's sort of good with it. I'm not.
So the short answer is, with anything we do with cloud services, we always do a fairly extensive write-up. It's a really good point, and it's one of the things like we will be publishing to the extent possible. Now, maybe not directly an answer to your question, right? But, and I'm just going to advance the slides a little bit. By the way, this is the GPS module. It's available today. It works on all of these access points. I'll answer your questions like maybe slightly different. What if you're in Europe? Or what if you want to use all of them 1200 megahertz? Or what if you're not comfortable about sending this information out of your network? Well, it's going around the room, but we took an external 6E antenna and we put it into an AP called the 91661. And for those of you who speak Cisco PIDs, this is 2566 merged into an access point. It's right over there. Tom has it.
Tom's keeping it.
With that, you do not need an AFC. You can use 1200 megahertz today. This works in Europe. We have events running it today. I'm not going to spend too much time on this one right now because this is public information. But just since you mentioned angling, just one little shout out to this line over here. There's an accelerometer in there. So in the very near future, we can actually determine the tilt of all these access points. So say you have a design file that has angles of installation on it, right? Now it can automatically determine, hey, where am I pointed? Okay, we can go a step further. Our partners in the RF modeling world can probably use this information. Or hey, did this installation actually change? So, you know, not a direct answer. And for those that need the information, yes, we'll provide that. But do you actually need external antennas? If you're in a high, low E building, maybe this is the way you go. Shout out to some of our engineers in Ohio who have called every glass manufacturer I know and said, can I get a sample of your glass to determine if GPS can go through that? Now, I want to shift gears a little bit here in the end and talk about, well, the elephant in the room, Wi-Fi 7, right? Now,
before you go, can I ask 2 questions that came in from Twitter?
Let's do that at the end, just because I know we're a little short on time, and then we'll take those. So, Wi-Fi 7, right? EHT, extremely high throughput. There's not a day where I don't get asked, what about Wi-Fi 7? And I'm sure you guys will as well. But first, I want to take a step back and say, you know, what do our end users actually care about from Wi-Fi? Most of them, they just want it to be fast enough, make easy onboarding, and have it be reliable. They don't care what generation of wireless is running. Now, in the beginning, I said 6E was what gave us a lot of this revolution that we can now deliver this in a way we haven't been able to in quite a while. And honestly, they just want to make it work. So I'm going to be a little bit cheeky. When people ask me, so 6E or 7, I'm going to start replying, if I know them, maybe not to the customer, that's a poor question. First of all, why? 6E is 6 gigahertz. By the way, you can get Wi-Fi 7 certified from anything we see when the cert comes out without having 6 gigahertz. So let's start, and I need your help. Start talking about 6 gigahertz and Wi-Fi 7 like this. What do you actually need? A better question would be, well, what might you gain from Wi-Fi 7 when it becomes available? Now, we'll come back to that slide I asked about earlier, Sam. Say, hey, you know, you remember the slide?
I'll pull it up.
A photo.
Yeah.
But, in that trifecta readiness, Wi-Fi 7 is not available yet. But let's talk about what is in there. What do we expect to be in the spec? Now, I have chosen 7 key features. I'm not going to talk about all of them. The lower 3 is mainly here for honorable mentions, and we can talk about that over coffee. But I do want to touch on kind of the big box sticker features you're going to see in any presentation about Wi-Fi 7. Wider channels, which is optional. 4K QAM to go faster, which is optional. MLO, which is going to be amazing when we get proper AP and client interop. Big line under when. And then, of course, enhanced security. Now, I am as much as a geek as anyone, hopefully, in this room. And we're going to advance it. That's a 160 channel in the blue line. When this shows up in your network, yes, it is fun to run 320 megahertz. Do I think we're going to see it in the enterprise? No.
No way.
Well, hopefully not. Is somebody going to set up some mesh link and do this to us? Absolutely, right? So 320 megahertz, nah, probably not in the enterprise. 240 and 5 gigahertz, no way. I mentioned it's optional, right? Now, I don't want to call out anybody here. Let's go to the next. There we go. Massive shout out to Intel, who have actually launched their first chips. I like data sheets. I get to write them. I get to read them. If you go in there, Intel has 2 chips. One of them, today, it will never do 4K QAM. It will never do 320. It's a 1K QAM 160. Because, clearly Intel doesn't believe we need that. Neither do we in the enterprise. Now, by the way, you may or may not be able to read that right now. There's no version of Windows that supports half of this today in Wi-Fi 7. If you run the earliest developer preview, kinda, right? So these are the chips that are out there today. On MLO, which is the other big sticker feature, I've called out not necessary answers, but considerations for this audience. You're all very, very smart people that know a lot about Wi-Fi. I would love to hear your thoughts on this, but this is how we see MLO. Now, MLO, multi-link operation, first of all, and I'm saying this because customers have asked me, they're saying, Nick, this is the one where client will talk to multiple APs at the same time, right? No, that's Wi-Fi 8. That's, multi-AP coordination. MLO is one client. Is there a question?
I'll tell you what the customers think, because there was literally an article today on Mac Rumors about the next iPhone. And one of the big banner features is that it's going to talk on all 3 Wi-Fi bands on Wi-Fi 7 at the same time for increased speeds. So that's what the non-techie people think they're getting when they buy the next iPhone.
Exactly. And thanks for sharing that. I didn't get to check my Mac Rumors this morning. But I wanted to call this one out. Like, let's start educating people about what MLO is and what it isn't. Now, it's probably going to be a 2-band, 2-link solution for a lot of these client vendors. I don't believe we're going to see phones blasting all 3 bands at the same time, because what's that going to do to the battery? And we're going to talk about the benefits in MLO in a second, but I want to kind of lay the foundation of what we're talking about here. Band isolation on clients comes into play. Hey, if you're transmitting on multiple radios, you need good filters. If you're transmitting on 5 gigahertz and 6 gigahertz at the same time, or, slightly offset, you need great client filters. Laptops and cell phones are going to be different in this space, right? Some devices might only ever do 2, 4, and 5. Some might do 5 and 6. Some might do 5 and 5. It's all in the spec, right? But reality, you need to do a reality check on what's kind of going to be in MLO in the real world. I've put here, devil is in the detail. How many of you are fully up to speed with single radio, multi-radio, synchronous and non-synchronous modes of MLO?
Almost.
See, almost, and this is this room, right? Consider how the customers may or may not be confused about all of this, right? They go to Mac Rumors and they read, this is going to be, 3-lane highway blasting on all bands at all the time. I'll talk about these in just a second. But these are the devils in the details. These are the things that everybody here needs to be on top of as we have discussions, intelligent discussions about how you could or could not design with Wi-Fi 7 when it's going to be available. Minta talked about client interoperability. I don't know about you guys. This is not an easy thing to do between clients and infrastructure. Oh, by the way, there's this little thing down here, and shout out to Stephen Orr for kind of highlighting, by the way, you need the same AKM across every link in an MLO group. I was joking about transition mode earlier. This is going to get a little more tricky. But before we go there, let's talk about the many modes of MLO. I've made it really, really simple. Just focus on the left one. There are different modes. Do you want to transmit independently two links, counting down individually, doing their own nav timers? There is technically a mode called NSTR, where both links must transmit at the same time, must receive at the same time. I don't think we're going to see that a lot, because now you have one channel holding the medium whilst it's waiting for the other channel to get ready. I see Keith shaking his head. Exactly, right? We're not going to see this. Links sending the same data at the same time. I did a Google on MLO. I've seen this described as a use case. And whilst technically true, that's not MLO.
It is. I mean, it's no worse than PRP over Wi-Fi, really, at the end of the day. So you could certainly, relegate some of those corner case scenarios to now a standards-based technology instead of something proprietary.
Absolutely, but this is not standards-based. That whole sending the same data is not a specs-based MLO. Now, you could do that at driver level. That can be implemented for sure. But it's not MLO.
It's not.
It's essentially using STR and just sending the same data over those two links, which are operating individually. So, key takeaway, just remember STR, forget the rest. It's what we're seeing right now.
What about the quaz when it gets to this? When you start doing the breaking up the access categories, and then there's two more called SCS and what's the other one? 802.1 QBV, TSN. Now that I haven't got my head around yet.
Sounds like a great topic for next MFD. I was told don't give a 2-hour tutorial on Wi-Fi 7 and MLO. Happy to do that for next one. By the way, SCS, Stream Classification Service.
Yeah, it evolved, right?
Exactly, and it kind of works along with one of the honorable mentions with triggered uplink OFDMA. If you go to Google right now and you type Cisco Fastlane Plus, the stuff we did with Apple, kind of basically just that. Anyways, it's just been Halloween. So let me scare you a little. I took an example of what could an MLO SSID deployment look like if we're using SAE in transition mode. Some might look at me and say, Nick, this is a worst case scenario. I say, well, this might be a very real scenario. So if you want to support BE clients or Wi-Fi 7 clients when they become available, this, same AKM across all of your links. So far, so good. By the way, there's a new AKM in town called AKM 24. So BE must associate with AKM 24. Great, so far, so good. Now you want to add in 60 certified clients. Well, that's AKM 8 and CCNP 128. Anybody guess what's going to be on the next line?
6.
Hang on. Advance it here manually. So if we're going to do older stuff, we now also have AKM 2 for transition mode. This is the reality you're going to be dealing with when Wi-Fi 7 becomes available. Now, why am I saying this? Because you're going to be the guys that are going to help these deployments. You need to start planning for this now. Now, AKM 8 and AKM 24 are somewhat similar. Same hash values, but there's absolutely no guarantee that a 6E certified device will ever know what AKM 24 is. From, let's say, reputable vendors, hopefully there's going to be updates. There may not be.
So just a purely, maybe stupid question, but is there ever a point where vendors like Cisco get a hold of a standard like what's coming out with Wi-Fi 7 and say, this is just insane, it's ridiculous, and as a block, we're all saying no to the IEEE? I mean, like I said, I know it's very rhetorical and silly, but because some of this is just so unachievable, and if you can achieve it, it's so non-uniformly applicable that it becomes self-defeating for not just us, but for you guys and everything.
So the short answer is we're present in every body where this is discussed. It is also very much a majority vote in a lot of these. IEEE, WFA, WPA, or the security group, present in all of them and leading these arguments. If Stephen Orr was here, he'd say, let's just all go to 1x and call it a day. And that is possible. We could all go to 1x and be happy, right? I'm not going to dwell too much on this, and I see discussions in the sideline, and could we simplify this if, we go, oh, by the way, the group cipher is all going to be CCMP 128 on the group cipher because that's 6E. Worth considering. I put down here, legacy client support is going to be fun. Even if you get rid of anything WPA2, there's now a bifurcation in WPA3. Anyways, Sam, this was for you. Going back to this, the model. So where are we?
Infrastructure regulatory clients. I got it. Boom,
Yes.
right there.
Regulatory specs, IEEE 4, version 4 of BE spec dropped 10 days ago. There is no such thing as Wi-Fi certified yet. Probably going to be soon. Clients, Intel dropped the first version of their chip with the first, the driver code, 14 days ago. So where are we in kind of like Wi-Fi 7 for enterprise?
Oh, we're waiting on infrastructure.
See, I knew that was going to come. But, we're right here with consumer Wi-Fi 7. I have the privilege to have all the consumer gear, all the phones, and I'm testing this out. If you buy a consumer Wi-Fi 7 router today, OFDMA is just turned off. It says 7 on the box. OFDMA, MU-MIMO is all turned off. So we're going to see consumer Wi-Fi coming in. Keith.
I just love this graphic. This is fantastic.
Thank you.
Yeah.
Credit to you guests who told me use this graph. But enterprise Wi-Fi 7, it's going to be a while. Minza talked about interrupt. All the stuff that's not in the spec, we're working with all the client vendors to make sure this is going to work as good as possible when it's ready. We're not rushing to put out hardware because, God forbid, what if there was a change in the spec? Everybody remembers what draft N, and we had pre-release devices X, Y, and C, right? Now, that brings me to my second to last point. Greenfield. The elusive greenfield.
Windows XP only.
That is Windows XP. Thanks for noticing. Yes. As I mentioned, when we start bringing 7 in, we're going to create legacy 60 clients. How crazy is that, right? First question. Does anybody know, and I see people scratching their head, what that first bullet relates to? So, Anand talked about standard power, and there's low power indoor clients.
Different classifications from the SVC.
Your device needs to get certified from the FCC to operate on standard power. Okay. Anybody want to guess how many low power indoor certified devices are in the FCC OET as of yesterday?
LPI only?
LPI only first.
600.
1,700 devices,
A lot.
which is a good number. Now, there is standard clients, there's low power indoor clients, and there's dual, right? So you can be certified on both bands. Anybody want to guess how many dual, by the way, there's 0 standard only. Anyone who guess how many dual certified clients there are as of yesterday, 11 p.m.?
Not many.
45.
Less than 100.
About 400, which is a good number.
Oh.
But what's the delta between those two? Clients that are not allowed to connect with standard power. This is not solved by Wi-Fi 7. It's not solved by the specs. Solved by folks like you, educating customers about what gear to buy. It's solved by folks like us, talking to client vendors, working in the regulatory bodies to the best of our extent.
I have a question. Since you're in this space, you might be able to answer it. If a client vendor made one that was a low power client, do they have to pay for the FCC to test it again to be a standard power client or to move to the dual? Is that they have to go back in the queue and get in the test cycle?
They have to provide a lab report, all of that. So that, and I should thank you for that question. Do we think, I love my Samsung S21. It was one of the first 6E devices. Do I think Samsung is going to go back, spend the time and money on certifying those devices? I don't
Probably
think
not.
so. Probably not. Some of the Apple devices, I sure hope so. Any M2 MacBook out there, right? Hopefully it's going to be certified for dual. But now it brings me to my second point. This security support. Do I think that S21 is going to get support for newer AKMs so you can run a cleaner network? I don't think so. I know, by the way, there's some mixed support. So when people ask me, why is there not a Wi-Fi 7 AP from Cisco right now? Where's like, well, we're working on fixing some of the bigger underlying challenges working in the industry. Of course, we'll have hardware ready when it's enterprise ready. Not even a question. So that's kind of our take right now on Wi-Fi 7. Now, final slide before my summary. Promise the switching folks to kind of bring this up. You're going to need more than 30 watts of power to run enterprise 4x4 full spec APs in the future. We're adding in more radios, MLO, more data, more CPU intensive. Of course, this is peak. I've seen some confusion, right? And yeah, speeds over 1 gig, it's absolutely reality. I don't think there's any questions about that anymore. So, to summarize, here are the 7, see what I did there, key takeaways. Wi-Fi in 6 gigahertz is a paradigm shift. It's not about the generations. We have a full portfolio of, I hope that's the meme you're laughing off, and my key takeaways here, but we have a full portfolio of gear that can help customers deploy 6 gigahertz wireless today. The clients are there, the OS support is there, everything's there. AFC is ready. Anand showed this. The moment the FCC says go, we're going to roll it out, and you can turn it on with, 1 or 2 button clicks. There is no such thing as Wi-Fi 7 certified yet. Do yourself a favor and understand what's mandatory, what's optional in the spec. I was personally a little surprised. Short to midterm, Wi-Fi 7 is only going to bring slight benefits in the enterprise. Once we get up to speed on MLO, yes, there is definitely benefit for lower latency on Wi-Fi when we get there, right? Client interop is going to be fun. Start planning around this whole, what does legacy 6E mean? If you're a higher education customer, you don't have a choice. Everybody bought M2 MacBooks and they're out there today. Plan for more than 30 watts. And well, the 7th takeaway isn't quite ready for enterprise yet. Cool.
Well, you answered one of the questions, but it generated a different one for me. So if I've got a standard power AP, can I run it in like a low power mode so that my non-standard power certified clients can talk to it?
Is it indoors? So if it's indoors, yes, right? Our access points are LPI. Can I take a standard power access point? Where did it go? There. That's free. Run that in LPI mode? Nope.
All right.
Can I run it in 2, 4, and 5 mode? Oh, absolutely. Does the client tell the infrastructure if it's capable of standard power? Nope.
No.
There's a beacon from the infrastructure to say I'm capable. But imagine this, if I'm an RRM algorithm and I'm going to decide, should I go to standard power to get that a little more transmit power? I have no way today, and we are working on this with some of the vendors, to know if my clients that are associated can even attach. That was forgotten in the specs. I'm going to be very honest here. And this is something we're trying to work. Vincent talked about partnerships to add these forgotten information elements in there. Cool.
There was another question. Someone asked if you can share which AFC provider you are using.
Really short. We're multiplexing across a bunch of them.
Okay.
So we can change, for uptime. If we see better data in one, we can, we've made that transparent. As Anand showed, it's a one-click thing, and customers don't really have to worry about that. And we can add them, on the fly in the backend.
Question regarding that too. So is customer data anonymized as it goes out to those AFCs? Like, are we only sending location information, or do they?
It's of course encrypted. The exact fields and values, I'm not going to stand here saying knowing exactly what's in there. We do have to send location. I do believe we actually have to, and Anand, keep me honest, we have to maybe even send device serial numbers to the AFC. So there's only so much we can do to anonymize it, right? Anything that could be personally identifiable to the extent possible within the rules.